Welcome! Today we'll solve a challenging implicit differentiation problem involving logarithms and exponential functions. Let's start with our equation. We're given that ln of xy equals x squared plus y squared. Our goal is to find dy dx. Let's solve this step by step. First, we'll use the logarithm property that states the natural log of a product equals the sum of the natural logs. So ln of x, y becomes ln x plus ln, y equals x squared plus y squared. Now comes the key step. We'll differentiate both sides with respect to x. Remember, when we differentiate ln x with respect to x, we get 1 over x. And when we differentiate ln y, we need to use the chain rule because y is a function of x. After differentiating, we get 1 over x plus 1 over y times dy dx equals 2x plus 2y times dy dx. Now let's solve for dy dx. First, let's move all terms with dy dx to the left side and all other terms to the right side. Next, we can factor out dy dx on the left side. This gives us the quantity 1 over y minus 2 y times dy dx equals 2x minus 1 over x. To simplify the left side further, let's get a common denominator. 1 over y minus 2, y can be written as 1 minus 2 y squared over y. Finally, we can solve for dy dx by multiplying both sides by y over 1 minus 2 y squared and x over 2x squared minus 1. This gives us our final answer. dy dx equals y times 2x squared minus 1 over x times 1 minus 2 y squared. This solution demonstrates the power of implicit differentiation and logarithmic properties in solving complex calculus problems. Remember to always check your work and ensure your solution makes sense mathematically.